This is TechSNAP, episode 364. Hi everyone, and welcome to TechSNAP, Jupiter Broadcasting's weekly systems network and administration podcast. We recorded this episode on April 17th, 2018. It's brought to you by our three great sponsors, DigitalOcean, Ting, and iXsystems. I'll tell you about them later on. My name is Chris, and joining me every single week is the admin, the engineer, and the presenter. It's Mr. Payne. Mr. Wes Payne. Hello, Wes.
Greetings, Chris.
Wes, are you ready to talk about server monitoring?
Oh, I sure am.
You've been in the trenches for many, many hours on this topic, so we're going to glean some of your knowledge, and we're going to talk about server monitoring, from why to monitor to what you can use. We'll specifically talk about Nagios and its alternatives, as well as a few resources, and then wrap it all up with your feedback. It's a real focused episode this week.
Yeah, that's right. We thought everyone would benefit from some real adult talk about monitoring.
Let's get real about monitoring.
Nagios is definitely one of those tools I've used in anger, and really this was all spawned because I've been spending the last week or so redoing the Nagios implementation at the day job. So we have an older one that's been it's gone on very strong. It monitors lots of things, but it really needs an update. It's going to be a lot more integrated with configuration management. So I've been in the trenches doing that. We'd been thinking about talking about this topic on the show anyway. It seemed like the perfect time.
It really is perfect timing. So it's just a great opportunity to sort of leverage what you do day to day. So let's start at the very top, somewhere where the audience has got to start. Why do you want to monitor? Now, I understand you already are, but like if you were hitting the reset button, what are you really trying to accomplish?
At the simplest level, I would say monitoring, it breaks the cycle of you're using something and you find out it's broken when you need to use it. I'm sure you've had that feeling. You're running a small service for yourself. Maybe it's a Quasal server or a database somewhere. You don't use it all the time, but you know when you need it, and suddenly it's not there. So monitoring lets you break that. Monitoring can proactively alert you when there's problems or even when there's potential problems, and so you can then prioritize, delegate, whatever you need to have happen. It starts that feedback cycle of what's actually happening on my systems.
It can also give you early indications of when maybe maintenance is due, or if a system is on the edge of failure and you can take care of it before you look bad. I mean, there is a bit of CYA.
Oh yeah, definitely. Especially if you are providing a managed service, if you have any sort of SLA, these are factors that are going to be hugely important to the performance of your job.
And I'm also going to just say, I also feel like decent monitoring and metrics can be a good security tool. Several stories, and in my own personal hands-on experience too, you've seen where an attacker was caught simply because somebody noticed a huge jump in bandwidth coming from the FTP server or something to that effect. In my personal day job, years ago, we discovered that somebody had compromised an FTP server that we had available to other school districts. And the way I discovered it was we had bandwidth graphs where this box that usually only got a little bit of traffic at the beginning and end of the month all of a sudden was busy all day, all night long. And we saw it right there in plain metrics.
Exactly. Once you can establish a baseline, you can then actually observe, deviations from that baseline.
Yeah.
But if you have no data at all, you're just in the dark.
Yeah, really. So then it really comes down to what should you be monitoring? And you have the network you need to monitor. There's aspects of that. And then you have your systems and your applications. And there's aspects to those you need to monitor. So what do you need to be monitoring?
To answer that question, I think you need to ask yourself, what are you going to want to know? When something's broken, when you are, trying to put out fires and investigate, what is the information you are going to need to know to validate your assumptions, to troubleshoot, to understand your system? That's where you know what to monitor. And every time you have a question like that you don't have an answer to, that's a great time to go make a new monitor, right? And add that data so that next time you have it.
One of the exercises you could run through potentially in your head is take one of your core applications and try to visualize all of its dependencies. So if it's a web application, it is dependent on a web server. It's dependent on a server being online. It's dependent on that server having a network connection. So it's also dependent on a switch. And it's likely dependent on a database. So you also need to have a database check to make sure the database is online, what the performance of the database is, if that server is online, if it's a separate physical host, if its network connection is active, and if the network it's connected to is live. And you can sort of work down a dependency tree like that, and you can sort of visualize the obvious points that you need to monitor and then expand it from there. But you can really see how like good documentation, a well-documented, maybe even visualized application diagram is really useful at these moments, which who really has accurate, up-to-date versions of those? I understand, but it would be so great.
And it can be a good exercise in trying to understand that, right? Periodically updating some of your monitoring, walking through your system, looking at those connections, and then asking, what do I need to know to validate that this connection is working? Yeah,
we recently just did sort of a reverse engineer of a project that was created by somebody that was working here previously, the Beard, and he had curated a bot for us. And we didn't have a full picture of how that thing was set up, what dependencies it had, and we had to kind of walk that chain down and figure out, okay, well, this is actually connecting to another system, and that's why it's not working. How do we make sure that we have a monitor on that now? And we thought we had everything covered, but as you learn more, if things aren't previously or properly documented, you just sort of, oh, here's another little boop spot to monitor, and you sort of grow it, you expand it.
Right, and in many ways it forms as a sort of an impromptu documentation. Not as good as, real documentation, but you get an idea of these are the things that are required for this application to function.
So if the core question is what to monitor, would you agree that it's really anything that can have an impact on system performance or network performance?
Yes, I would agree. I think you do have to consider scale and scope and what your needs are. Any monitoring is going to be a lot better than no monitoring. And it takes time, right? It's not feature work. It's not actually like building new stuff. So it can be difficult to get around to. So I think everyone ends up doing some level of just basic system monitoring. And that's just, you can argue, there are more ways to get more leverage, but they're so easy. They're so common, and you can easily find preventable problems, things like high CPU usage or your disk space is filling up faster than usual.
Okay, well, let's talk specifics here for a second then. What metrics would you want to collect? It sounds like CPU, memory, and disk metrics. So you have, over time, at least some snapshots of what's that. What event messages or system log messages, I would imagine you'd probably want to capture that. Network interfaces, any other kind of performance indicators you can get. Depending on the type of system, there's maybe web server specific or database or even print job specific things you could monitor. What are any other things jumping out at you that you might pull off a server using a monitoring system?
Yeah, you'll frequently see, you'll see hard drive space, load average. One thing a lot of people end up looking at is the fork rate, just to see if there's some process that's spawning a whole bunch of other processes.
That's a great idea.
If you have a swap on your system, that's going to be another one that you'll probably want to look at. And if you're running in a cluster, you probably have an NTP daemon running, and keeping time in sync can be very important, especially for distributed systems.
So that's some high-level basics of monitoring itself. We're not even getting specific into what you're monitoring with. But what are some other advanced things you can do to sort of prep yourself for monitoring?
Yeah, so once you've got basic system health down, if your machine is upright, you're doing ping checks, that it's healthy, that it has its disk space. That's where you're going to want to start looking at your individual applications. If you're running a database, oftentimes there's ways to pull metrics, look for failures or notifications or alerts in the logs. So log scraping it's a whole own topic that we can cover more in depth, but it's definitely important as a source of information. You'll also want to start instrumenting your applications as you design them, thinking about observability, thinking about how to monitor all the dependencies, all of its interactions, so that you can really get a white box monitoring approach, understanding the internal mechanics. Both approaches are valid, right? You do need black box end-to-end testing sort of monitoring approaches.
Sure.
But it's also very helpful to be able to understand the internal workings. All of those are more advanced. Those are like upper levels, especially as you're running like a larger scale service.
But you're talking about literally building your in-house application so it can be monitored.
Yeah, you have to start thinking about it from the very start.
Yeah, that's a great point. It makes me think back on JBot. How could we rebuild JBot so that way it is designed to be monitored?
Yeah, and there's a lot of frameworks now. If you're using Prometheus, for example, they've got a lot of instrumentation libraries available for common programming languages. StatsD is another common format with all sorts of backend systems you can run, a common format for tracking things like gauges.
All right. That's the basics and a little bit of the advanced. I like that. So now let's get specific. do.co/snap. DigitalOcean is infrastructure on demand as fast as you could imagine around the world. Everything SSD powered. That's it in a nutshell. You can deploy in less than 55 seconds. They have 12 data centers around the world, and their pricing will blow your mind. My favorite system, which isn't even the lowest cost system, is 3 cents an hour. 3 cents an hour at DigitalOcean. And when you go to do.co/snap, you'll get a $100 credit.
We were just talking about the importance of basic system monitoring.
And DigitalOcean has that built in. You can learn more on DigitalOcean's website. Go to do.co/snap. It's pretty nice. It has alerts for all kinds of metrics like CPU, your incoming, outgoing bandwidth, your disk read and write, memory usage, disk usage. It supports notifying you via Slack, and they will graph your metrics, which is a feature that we both love. I use that specifically for our DigitalOcean droplets that are doing CPU encoding and restreaming while we're live. So I can get an idea when our stream usages go up as we go to more and more endpoints when it's time to upgrade the droplet. And right now, my 3 cents an hour machine is more than handling it. do.co/snap. Go there, learn more, and get a $100 credit. Try out their new flexible droplets for $15 a month. You can mix and match resources depending on what you need. Enjoy Spaces, their S3 compliant storage solution. Or if you want traditional block storage, you can do that too. do.co/snap.
Today, let's focus on Nagios. In particular, we're going to focus on Nagios Core, which is the main open source component of Nagios, as well as the Nagios plugins project, and a few other related add-ons to Nagios. There's a large community of Nagios users, and that's one of its main strengths. There's tons of plugins, tons of guides, tutorials, configuration examples to reach out to. You'll probably need them because it can be a bit arcane at times, and there are a lot of config files. But at its core, Nagios is pretty simple. You can think of Nagios as two pieces, a web front-end dashboard that kind of gives you an all-up display of everything that's being monitored by that Nagios server, and then a background, basically task-running process, or sort of like a more structured cron.
Super cron.
Yeah, right. A super cron. Yeah, you have a whole fleet of different plugins and commands you can use, and then you configure a bunch of hosts and services. Services are attached to hosts, and then the services run on some sort of schedule. And every time they come up, they'll run your check. They'll report back. If the state changed, you can configure Nagios to send you notifications, or you'll see it if you go and visually inspect your Nagios. That's 90% of what a Nagios is used for. You've configured some checks. They run at intervals. They report back, and if their status changes, you get notified.
And those checks are a lot of those metrics we mentioned earlier in the show, like CPU load, disk usage, things like that.
Yeah. Also super common is checking on remote endpoints. You're checking that a HTTP request goes through. You're checking if an FTP server is available. Maybe you're just doing, just ping checks a lot of times, making sure all your hosts are up. And a huge component that Nagios is, you'll see a lot, is in physical data centers, anywhere running devices using SNMP, Simple Network Management Protocol, which is a interface on a whole bunch of actual hardware, and sometimes the only way to get any real information or metrics or monitoring on those devices. Yeah. Nagios has a lot of plugins to do that. You can walk trees, you can check on specific OIDs, you can even receive traps if you configure it correctly. So it has great support there.
You mentioned that web interface. You can also use that web interface for checking previous notifications, problem history, and if you set it up correctly, Nagios can even understand dependencies. So if a switch goes out, it'll understand that perhaps this entire rack of servers could potentially be offline and accommodate for that. But you have to be able to do that, set it up.
Yep, right. That requires a lot of configuration. It has a couple other features kind of like that. It has flap detection, a lot of different options for scheduling downtimes or configuring when or how notifications get sent. I will caution people, the configuration can be, it's easy to get into a situation where you have created too much configuration or an overly complex setup, especially if you're starting and you try to be too general at first and you end up with complex hierarchies of different host templates and services, and making a change requires tracking back through like 5 different Nagios configuration files.
Yeah.
So start simple.
Yes.
And you can generalize as needed.
I want to underscore that because I think that was the number one mistake I made the first time I tried to deploy Nagios. Is I made it way too complicated. I had 47 different branch locations, and I had servers and client machines and printers all within these different locations I was trying to track, plus 2 data centers and a DR site. And I just went nuts because I thought it needed a really complex configuration, and I just created myself a kingdom which collapsed around me and really turned me off of Nagios for a long time. But it was on me. That was my fault. And so I really want to double recommend your advice to go slow, go simple. Yeah,
right, exactly. And it gives you a lot of nice tools for those kinds of scenarios where you can sort of branch off as needed. But if you do it too early, if you do it too often, when essentially systems aren't actually that different, you're just going to give yourself the cost of complexity.
So complete the picture for me. We've talked about checking different aspects of a server, but how do we go deeper? How do we get like actual disk usage information and things like that off of a server?
Sure. So so far we've kind of mentioned, you can check an HTTP endpoint, and this all happens, there's a commands configuration file there. You can define scripts that you've placed at certain directories, giving them name, and then, when you define a service, you can say, check my main homepage. Here's the endpoint, use the check HTTP, make sure that it returns 200 and looks like this.
Right. Nagios can do all that server side. It doesn't ever really need to talk to the host other than connect to a web server, make sure a page loads. But how does it get detailed metrics off of a host?
That's a great question, right? So it makes sense. So far, mostly here, you would have defined some commands local to Nagios that would run a script on the Nagios server, execute some function, return data, return a check result. To take it to the next level, you need NRPE, or the Nagios Remote Plugin Executor. This is a service that you run local to your remote hosts. So it's running there, it exposes a port, and you've configured it with a set of known commands. The Nagios server can then make a request that they run this command from a prescribed whitelist of commands. That will get executed, the data is returned, shoved back to Nagios, and then that is used as the check data.
I see.
I would like to mention there is a commonly used insecure option. It's now no longer enabled by default, at least in Debian and downstream projects. Basically, it allows you to pass arbitrary arguments to those functions on the remote host, and obviously that has some serious security ramifications. In some environments, it might be fine, but I would really recommend, if you have the ability to, just configure all those arguments on the remote side. Don't leave that open to Nagios. And that way, all Nagios is doing is just saying like, hey, run this totally predetermined script that you can audit.
Yeah.
Return me the results. It's a lot easier to audit that way.
Yeah, and safer.
The real power here is that Nagios plugins are pretty stupid simple to write. It's basically all done with return code and then some stuff printed to standard out. So if you can write a simple bash script, you can write a Nagios plugin, right? So you can shell out to anything else. You can compile a program to do it, whatever tools you want, as long as you can participate in that basic interface. So it can be a plugin.
At its core, Nagios is just looking for a yes, no, 1, 0.
Usually it's warning, critical, or clear. I mean, they have a scale. They have a really actually pretty decent documentation about how to write one of these plugins. But yeah, it's just a return code.
So, okay. And so if you can create anything server-side, Nagios just needs that return code.
Yeah, exactly.
No wonder the plugins are so popular.
Yeah, so it's super simple. You can convert just about anything to a Nagios plugin or wrap something else. So with that power, then you can have arbitrary scripts on the Nagios server side, or with NRPE, you can have them on the remote host side. Anything you want to do, complicated checks, run integration tests if you want, scrape/proc if you have specific needs. Maybe you have your own kernel module and you're trying to get statistics from that. Really, the sky's the limit.
We wanted to start the topic of server monitoring with Nagios because it's the clear leader. It's got a huge community, tons of documentation, lots of examples, books written about it.
It's been around since 2002, so it's a heavy hitter. Basically, anyone who's been in that space has used it at least somewhat. But it has some downsides.
iXsystems.com/TechSNAP. Go there to learn more about iX and support the show. iXsystems.com/TechSNAP also has a white paper you can download, read through that, and maybe help convince management up the chain to switch to a better hardware solutions provider. If you need storage, large compute, whatever it might be, iXsystems can custom build a solution for you. They really are leaders in open source storage solutions, and they're really proud about the new TrueNAS M series, and I can see why. It represents the next generation of TrueNAS and meets the performance and data growth needs of file serving, backup, virtualization, media production, and of course, building your own private cloud. The M series is a 4U form factor with 24 drive bays. And you know what? I'll leave it as an exercise to you to go look at the specs, but 3 terabytes of RAM is your teaser.
Ooh.
3 terabytes of RAM in the new TrueNAS M series. Of
I
course,
want it.
You can spec that thing up with crazy amounts of NVMe. It has all kinds of I/O. Okay, here's another teaser. I can't help myself. 4 active 100 gigabit Ethernet ports on this sucker.
Nice. Wow. Okay, I'm just drooling now.
That's the tease. You got to go to iXsystems.com/TechSNAP to learn more. And while you're there, check out the blog. They got some write-ups about the TrueNAS M, as well as the new version of TrueNAS OS itself, TrueNAS 11.1. iXsystems is leaders in open source development, integration with hardware, and then wrapping it all up with a white glove experience. It's who you want your systems built on. iXsystems.com/TechSNAP.
Nagios has been around for a really long time, and I think that is ultimately a testament to it's practical, it's usable, and it is used in a number of places, and it does a great job. But it's also seen a lot of change, particularly in the last 10 years or so, as we've moved into cloud, as we move to more dynamic infrastructure configurations. It's really starting to show some weaknesses. Not that it's bad. It can still be put to great use in data centers, in more static environments for just basic monitoring of hosts that don't change very often. It works splendidly. But this notion of hosts and services attached to hosts and groups of hosts, it's built into the model of how Nagios works.
Absolutely.
And so with modern services, if you're monitoring an auto-scaling group of EC2 instances that are ephemeral, change, come and go. Maybe there's a Lambda in the background doing batch processing work from an SQS queue. You can monitor all of those with Nagios, but there are probably better tools that you should invest in that you don't have to fight against the abstractions that are built in. It's also somewhat software from another era in its build and configuration. Most of the time, if you're going to want an up-to-date modern version, you're going to end up building it from source yourself. It's mostly written in C, so you're going to be, make installing on your system. If you go through some work, you can get it packaged up or build or find a PPA, and that's a little bit easier. It's also an older style CGI application, so you're going to be running and configuring Apache, configuring CGI, running Nagios that way. None of that's bad, and it all definitely still works, but it's not a simple server that you start and then proxy Nginx to. It's from a different era, and it has a lot of config files. As we mentioned earlier, it's easy to go overboard there. It's also just a lot to take in from the command line, and it doesn't necessarily have that great of defaults. It can be a little bit challenging to get even to just like a base layer of like, here's my 3 example hosts with a couple services. So it feels like instead of hitting the ground running and then modifying from there's often a lot of sort of mucking around trying to get it to work. One tip it does, and it will tell you this too, but Nagios-V and then the config file, you can run that all the time. That'll try to do a check on its config, verify that it's in a consistent state, point you to any errors in your configuration. So that's super helpful. That can help speed up the process, but it's just not, it feels out of date in those ways. And that's okay. You have to deal with it. It's still super useful. Just be aware of that. Also, in its default configuration, there are plugins to help remedy some of this, but in its default configuration, it often just ends up providing you more snapshot-like data. Every so often it goes around, runs a check on a server, reports back. So
it's very specific point in time, though.
Exactly, right? So you get an idea of like, is my host healthy right now? And yes, there is, you can keep historical data and you can look through that and past alerts, but it's not a rich history of what happened. It's more like, you get point in time snapshots of what's the state of my host? Is it healthy or is there having a problem? And that works really well for break fix style stuff where, the disk space is, over our warning threshold.
Yeah, or the server is up. And is it up or is it down, or how long was it down? It's good for that.
Right. And there are some things like that, right? Yeah, like, is it up or is it down? You don't really, you might care about uptime charts at some point, but not really. That hits the basics. But for other things, for like load histories, latency spikes, bandwidth used, it can be often helpful, especially if you're running complex systems that you want to understand. You want graphs of the past. You want data that you can actually use to review, build trends, maybe do some sort of predictive monitoring. That is sort of outside of what Nagios is good at. You're going to end up having to build a bigger system. And Nagios can be a piece of that, but it won't be able to do all of that. And I think that's another thing about it is it's not always the most composable system. It really feels somewhat like an object-oriented system with a lot of hierarchies. That can work really well. Like you're talking about, okay, I have 6 different data centers and each data center has 2 different types of hosted. Like for something like that, it can work really well. And it can do some limited amount of, yes, the switch is down, so these services are down. It's not great at that though, and it's very statically defined, so it won't react to It's very hard to do something like, okay, well, if it deviates 10% above the average from the last half-hour time period, send me an alert. That stuff, really difficult. Or if you want to check like, okay, send an alert, but only if these 6 other services are also an alert and some other arbitrary predicate over there, you can't do that either. So it works super well if you can say, I have a script, I want this to tell me yes, no, is it broken? For anything else, you're probably going to want to at least start collecting metrics that you're sending to some backend graphing or analysis system. It gets more complicated because you end up having to, very much in the Unix philosophy, you end up having to build pieces together, sort of figure out your own system for it. That's where Nagios is also so helpful at the beginning because you get this dashboard, you get all that stuff. So it works great for that base level. You can build from there as you have time. They have a couple of things. One is Nagios Graph, which provides just like it takes performance data and past data, builds RRD graphs from it, and lets you display it there in the UI. So that's pretty helpful. If you're using something like InfluxDB or Graphite for metric collections and storage, Graphios is a plugin that will basically take that same performance data, convert it to Graphite format, and send it off. So that is one way you can get a pretty easy, bridge that gap where you're already checking like how full is the disk. With a plugin like that, you can send that information off to a server, store it, and then you can start building those, that history and looking at those charts.
We'll put some links in the show notes at techsnap.systems/364 if you want to get links to some of the stuff Wes mentioned. So that's some downsides. What about some of the criticisms that I've seen online that it's just not a good fit in more automated environments where perhaps you're using Ansible or Chef? Do you agree with that criticism?
Yes and no. In automated environments or environments that change a lot, it can be tricky. I think you can get it to play all right. I'm integrating it with Chef more right now, so it depends on how much work you want to do. You can leverage, specifically Chef, you can leverage the inventory that Chef has, right? You have a bunch of nodes defined there, so you can use that to render out Nagios configuration, but on anytime that changes, basically you're going to be, having Nagios reload its configuration. It doesn't have an idea of any sort of like runtime updates. I mean, it does a little bit, right? You can send it SIGHUP, it'll reread its configuration and that sort of thing, but it's not like you can dynamically call its API to do stuff. It does have an API. You can do that, but it's all sort of tacked on and not really part of its core. So if you're going to be using configuration management to define it, you definitely can. You're basically just going to be templating out the Nagios configuration files.
Okay, we've been promising, so let's discuss some of those Nagios alternatives.
Yeah, I think the first one, naturally to start with, is Insinga 2, which is a fork of Nagios. They split quite some time ago and have both been very actively developed. A lot of the plugins are kind of developed by both, and there's a lot of cross functionality because of the simple plugin interface. It means you can port them a lot. So they're really complementary communities. It has some different features. I think its API is a little more well developed. You can go check it out, read the docs. There's lots of tutorials and examples online comparing them too. So it's definitely right in the style of Nagios. Nagios is, it's been around so long, it's spawned a lot of these systems, either inspired or are actual forks of it. Another one that comes to mind is check_mk, which is an extension to Nagios that adds some more configurability and some additional features. So you can find plenty of sort of Nagios clones. Another popular system that's been coming up is Sensu. And Sensu, I think, keeps a lot of the same basic ideas of Nagios. It's also, you get nice dashboards. It has a lot of the features. It's basically a complete system that you can deploy. But it's a lot more modern, right? It uses like it has RabbitMQ between agents. It has a lot more dynamic features. It has first-class support for configuration management, so you can tell it to go ask Chef for all the nodes that you want, and then it has like you're not hacking it around by updating text config files. It's built into the system. So I haven't deployed Sensu personally. It's one I'm keeping my eye on. If you want to stay sort of in that realm of Nagios style, but you want something more modern, something that wasn't designed almost 20 years ago, check out Sensu.
Okay, so what if I'm looking for a solution that isn't as broad as Nagios, something more focused on metrics?
Yeah, sure. Metrics, time series data, that's really at the core of a lot of monitoring stacks these days, especially in bigger companies or more complex distributed applications. Now, for this, and we're going to leave it not really as part of this discussion right now, you will probably need some sort of metric storage backend, something like InfluxDB, Graphite, Prometheus. There's lots of options there, and there's also a number of paid services that you can use. If you have one of those, you'll need an agent. And the two I've really been fond of in the past and recently, the first is CollectD. And CollectD's been around for a long time. It's kind of a Swiss Army knife tool. It's small, pretty lean, written in C, available on most platforms. And it also, like Nagios, has a ton of plugins. So it can monitor all the basic things you want, memory, CPU, disk, has a bunch of plugins for lots of applications to monitor them as well. It can act as a StatsD server. If you've implemented your application with StatsD, CollectD can do that. It can send all this stuff to Graphite or Influx or all kinds of tools. It can even execute Nagios plugins. So if you have Nagios, or maybe you're trying to move away from Nagios and you're trying to build a little bigger system based around metrics,
or you want to take advantage of all their plugins,
CollectD is great.
And this is something you just run on each individual host.
Yes, exactly. So an agent runs on each host, collects metrics, and then you've configured it to send to your backend system. Those systems usually do aggregations. They might compute functions or views on that data, and then you tie it in with something like Grafana or maybe something that's built in to actually go look and make dashboards of all that data that you've collected. The other tool I'd like to recommend in that space is NetData. It's relatively new. It's produced by the same people who make the Firehole firewall configuration for Linux. Both tools I enjoy a lot. NetData is rather than like a package, they have an installer script, but it works pretty well. I think they actually have some static binaries they're using now too, so that makes it a lot simpler. A great thing about NetData is it comes with a pretty full-featured dashboard. So right out of the box, it runs a local listening port, pops up, you go there, it has a very nice interface with a bunch of dashboards, a bunch of configured metrics already, like tons. Some stuff, it's maybe even a little noisy by default, but you'll probably learn really quick if you have some misconfigured settings or if your system's really using a lot. And they've done a lot of stuff. They have some pretty tight care about, how much of the host resources is this going to use, right? They're really cognizant of that. So if you're not looking at the window, none of the graphs go. All the graphs are computed in the browser, basically just from data not computed on the host you're monitoring. They've also added some features where, you can have one host that then pulls data from other NetData servers. So they're even getting a little more into that distributed setup. Not really its primary focus, but it has that capability. It also has a capability of acting much like Nagios, where you can configure alerts based on the metrics it's collecting, and then it has endpoints, so it can integrate with email or PagerDuty, or even send to a Nagios instance if you wanted to. And of course, a very popular solution in the time series space is Prometheus. Prometheus is inspired a lot by Borgmon, which is Google's internal monitoring system, or at least it has been. And it's really been developed sort of not impairing, but sort of next to Kubernetes. And it's designed, Kubernetes also inspired from Google's Borg. So there's this symbiosis. It really is cloud first. It's under the cloud native computing foundation, and it's really time series focused. So they provide a bunch of libraries you can use in your applications to instrument them, have white box monitoring, and they provide a bunch of their own agents as well. So their node exporter, for instance, runs on a node, scrape/proc, comes up with all kinds of statistics, sends it to Prometheus. Where Prometheus is interesting is it, much like Nagios, provides you this, it has a dashboard, it shows you graphs, it has an alert manager, so you can configure alerts based on those time series. So you can really write much more complicated, more composable alerts because you have access to all the data. You send all this data to Prometheus, and so you can make complicated queries across it so that, when the CPU is between these ranges, but the disk is this, and the application state is this, it can get very complex, but that's its power, and it's right there in one system. They have a bunch of defaults. If you have a Kubernetes cluster, you can run Prometheus inside of it and monitor the cluster, tons of integration. So if you want to go full time series, and it really is, at least so far, been a huge trend in this space, check out Prometheus.
Prometheus!
Now, there are a ton of tools in this space. We couldn't touch on all of them. So if we've missed your favorite, or you have any experience with one of the things we did talk about today, write in, let us know. TechSNAP.systems/contact.
TechSNAP.ting.com. It's a better way to do mobile. It's awesome because it's only pay for what you use. It's $6 for your line, then your minutes, your messages, and your megabytes. Whatever you use, that's what you pay. I get very, very, very little text messages other than a few automated systems. So 1 or 2 texts, 3 texts a month, no big deal.
Why would you need to pay for 1,000 or unlimited? You'll never use it.
It's crazy, Wes. That's crazy talk.
Crazy.
TechSNAP.ting.com will take $25 off a device if you want to buy from Ting directly. Or if you have a Ting-compatible device, and they have CDMA and GSM, so you might have one that's already compatible, they'll give you $25 in service credit. They have a great control panel that you manage every aspect, including turning off individual aspects of your service, and let you nickname devices. If you have a whole fleet of devices, you can keep track of Wes's device and, Chris's device and Angela's device. It makes that really nice. And if you're a small business, $6 a month for a line means, and with no contract, no agreements, means that I can just buy a couple for Linux Fest Northwest, use them for the month of April, and then just decide which ones we want to keep with no ramifications.
Oh, that's perfect.
I love that flexibility. And also, speaking of flexibility, Ting's all about it. Go to their blog. They have a new post on how to listen to audiobooks that are free legally on your mobile device. Pretty handy. Start by going to TechSNAP.ting.com. That's TechSNAP.ting.com.
Thanks for going to TechSNAP.systems/contact.
Like Dax did. Dax writes in this week, he said, after hearing about the embedding of zero-width Unicode characters into plain text and then embedding that code into different applications, I got some ideas, I was inspired, and I had to try it out myself. So I wrote this simple encoder and decoder function in Python, and I thought maybe I'd submit it to the TechSNAP audience and let them iterate on it. He welcomes some pull requests. It's at github.com/daxm. And when you go in there, you'll see there is a simple script. But in his email, he actually included the URL to the encoder-decoder script, but he used zero-width Unicode characters.
Oh, that's so evil.
So you got to use the project itself to decode it in the first place. I love it. Dax was having some fun. TechSNAP.system/contact for your thoughts or anything that you want to ask us or anything that we have inspired you to do, like Dax here.
Oh, that's just great. Yeah, it is a simple script. It's like 60 or so lines of Python. Go check it out. It's neat.
And that brings us to the end of this week's TechSNAP program. But Wes, there are ways to get more of us.
Oh, there sure are. If you want more Chris, go check out Season 2 of Tech Talk Today that just kicked off. It's over at techtalk.today.
Oh, thank you, sir. You can go get more Wes at Wes Payne, or go get the both of us at Linux Fest Northwest this year, April 28th and the 29th in Bellingham, Washington. There's only like 1 or 2 more weeks to plug this, and then we're there live at Linux Fest. It's going to be pretty cool. So yeah, check that out, linuxfestnorthwest.org. Also the network at Jupiter Signal. Our subscribe page is techsnap.systems/subscribe. And one more plug, skis, because why not just overload you on URLs on our way out of here?
Do it.
Let's just do it. techsnap.systems/364 for the links to the stuff we talked about today.
Thanks so much for joining us.
We'll see you next week.